Good afternoon, everyone. Thank you for joining another session of the GSE UK Virtual Conference 2021. This is session 5AV with Marna Wally and Steve Warren from IBM. And they will be talking about the IBM zOS on the z15 hardware. As normally, any questions, please raise them in the chat box, and Marna and Steve will be answering them. Steve, the floor is yours.
Hi, and welcome to IBM zOS on z15 hardware. My name's Marna Wally, and I'll be co-presenting the session with my friend Steve Warren. We're both from Poughkeepsie in New York, and we're very happy that you're here.
Hi, and I'm Steve Warren, Marna's partner in crime for this presentation. As Marna said before, we both work in the IBM Z laboratory in Poughkeepsie, New York in the United States, and we both love presenting at the GSE UK, one of the premier locations to find the very best information about IBM Z technology. So why don't you come and join us as we dive into zOS support for the IBM Z15. Let's just take a quick look at the agenda. We're first going to be focusing in on some of the IBM Z15 functions in general, kind of an operating system agnostic view of the IBM Z15. We will then journey into looking at which zOS releases are supported on the IBM Z15. We'll then take a look at some of the coexistence and functional PTFs which will be necessary to apply in order to run on the Z15 and to exploit some of the features that we'll be talking about later. We'll then talk about some both general upgrade considerations as well as sysplex and multi-system considerations that you need to be aware of when you're using zOS with the IBM Z15. Last, but certainly not least, and where we will be spending the vast majority of our time, we will be focusing on exploitation considerations for some of the top zOS functions that exploit the IBM Z15. Let's talk a little bit about the IBM Z15 server itself. The first thing we need to talk about is the fact that there are two distinct models, the model T01 and the T02. The T01 is analogous to prior Z generations of hardware's enterprise class servers, while the T02 is analogous to business class servers. One of the major features of the Z15 is its form factor. Both T01 and T02 models adhere to a 19-inch standard rack form factor. This is ideal for inserting the Z15 inside of your data center that has traditional rack frame size requirements. Another distinction of the Z15 is that the Z15 can handle up to 190 processors inside. In the Z14, there were up to 170 processors, so there's an increase there. Another improvement on the Z15 is the amount of memory that resides, the maximum number of memory that can reside inside a Z15. On a Z14, the maximum was 32 terabytes, while on the Z15, it's up to 40 terabytes. And one thing very exciting for zOS in particular, if you're running with zOS 2.5, you can actually increase the size of the memory for a single LPAR up from 4 terabytes to now 16 terabytes for very specialized configurations where a large LPAR with lots of memory is required. Another major enhancement to the Z15 box, of course, is new Z15 machine instructions. And those new machine instructions, again, provide additional capabilities as well as additional performance to existing operations. To leverage those new hardware instructions, there are new architecture levels and tune levels that your COBOL, PL1, and C programs can leverage to be able to generate these new hardware instructions. On the right-hand side, you'll see a bunch of things related to some new features. We'll be talking about some of these new features on subsequent slides. But just as a quick summary, system recovery boost, on-chip compression for EDC, a new CF level with some new capabilities in that space, as well as many new cards that go hand in hand with the Z15, such as coupling link cards, Rocky generation, new generation of Rocky cards, FICON, OSA Express, Hyperlink, and finally Crypto Express. The T02 single frame model has many of the same features as available in the T01, but with smaller specs. That being, for example, up to 65 processors instead of 190, up to 16 terabytes of memory instead of 40 terabytes of memory. Otherwise, they're quite similar in nature.
Let's look at the matrix of the zOS support summary and see what releases of zOS we can run on Z15. So looking at this chart, you can see that we can run zOS 2.1 or higher on Z15. And we know this because the column for Z15 indicates that. Now you'll also see that zOS 2.1 and 2.2 is marked in red, and that's because those releases are end of service. So you would require a service support contract if you needed to report any problems on those release levels when you are running a Z15. Also note that we can run zOS 2.5 on a Z15, and as you know, zOS 2.5 is our latest and greatest release. Looking at what capabilities now you have for each of the zOS releases on the Z15. As I'd mentioned before, the minimum level that we're going to support is zOS 2.1. So that's really just toleration support. So if you want the bare minimum and you want the capability to run zOS 2.1 on a Z15, you'll just have to add some PTFs to 2.1. But do remember that it has been marked end of service. If you want a little more exploitation, you can get that on zOS 2.2, but remember that zOS 2.2 is also end of support as well. So 2.3 has a little more exploitation than 2.2. 2.4 has even more exploitation, and 2.5 has exploitation the same as zOS 2.4 as well. So as you can see on this slide, the amount of exploitation support you're going to have for Z15 really depends on the level of zOS that you're running. And the higher the zOS level, the more exploitation support you have. So let's now move into PSP buckets and fixed categories, because this is all really important. Now that you know which zOS release level you're going to be running on the Z15, we're getting into the discussion now of PTFs. So how do we identify PTFs? Of course, we identify them with SMP fixed cats. So I also listed here the PSP bucket that you can find the identification of the fixed cats are, which would be helpful as well. So what we do for fixed cats is we have 3 categories of fixed cats. And these 3 categories, it's absolutely imperative that you understand what each one of these categories is telling you. So we have required service, we have exploitation service, and we have recommended service. Okay, so it is very important that we have these 3 distinguished in your mind, because when you ask the question, what are the minimum number of PTFs I need to install and where can I find them? These fixed categories will answer that question for you. So let's look at the required service fixed cats first. So as you can see here, we have a required service fixed cats for the T01 and the T02. And these would include the absolute minimum level of PTFs that you need on your zOS release system to run a Z15. So when you ask the question, what's the minimum number of PTFs I need? It's the PTFs that are identified with this fixed cat. We intentionally try to keep this fixed cat PTF group very small in order to minimize the amount of change that we need for you to have on to run zOS on Z15. Now let's look at the second category, and that's exploitation. Now that one's easy to understand as well, because if you're going to exploit brand new functions that are present on a Z15 and you want to do that with your zOS system, you would need PTFs identify with the exploitation fix cat so that you could have those installed before you did that exploitation. Now, the third category is recommended, and recommended gets to be a little bit confusing for people. So let me explain what recommended is. Recommended are the fixes that we want you to have on in order to run a Z15. So these might be ones where we have defects and customers have found problems, and we open up an APAR, we provide a PTF, and we don't want anybody else to hit those and have rediscoveries, and so we mark those as recommended. Now, are they absolutely needed in order to have on the Z15 on your zOS system? Well, it depends. Do you think you would encounter that similar problem again? So we need you to kind of look at those recommended fixes. And in some cases, you might want to do a little investigation, even contact IBM service to ask them questions about it. But if you can, it would be good if you could put the recommended ones on. However, it is not absolutely required. That is why we have the recommended fixed cat category, and we also have the required category. Okay, so that hopefully will help explain what those three categories are. Interestingly enough, the recommended service is also found in the PSP buckets, which is why the PSP buckets are listed on this slide as well. But the required service in the exploitation service, only the fix cats are listed into the PSP bucket. So don't be misled that if you look in the PSP bucket and you see the recommended fixes, don't be misled that you think they're the required fixes. They're not the required fixes, they're just the recommended fixes. Now, as you know, whenever we have new hardware support, typically we have crypto that needs to support it as well. And in the past, crypto has done that by providing a web deliverable. So they put their new FMID into a web deliverable, they put the web deliverable out on the web, and then they sell to people, oh, there's a great new hardware function out there. If you need the cryptographic support, you got to go to the web, you got to pull the FMID in, you got to SMP receive, apply, accept it, and then you got to get the PTFs for it, and you got to, receive, apply those PTFs, and that's really a lot of work. So what we have now is a future intention for crypto, and that is that they will release no more web deliverables. What they will do for hardware support is they will provide PTF support. And what's so wonderful is we can have those PTFs marked with the fix cats that I just described to you, those three categories of required, exploitation, and recommended. And they would now apply to the crypto users as well. But in order to get positioned for this, you really need to be on the last web deliverable for crypto, because that is the basis for where the future hardware enhancements will come. So if you're not yet on HCR77 Dog1, go get that web deliverable and incorporate it onto your system, install it on, and then you'll be well positioned for future PTF enhancements. But also remember that when you get to zOS 2.5, you won't need to install that web deliverable anymore because you will have a new FMID in 2.5, which is HCR77 Dog2. Now let's look at some upgrade considerations in general. So in general, these are things that you probably already know if you've done prior upgrades in the past of new hardware and putting zOS on the new hardware level that you get. zOS doesn't have to have a Z15, T01, and T02. As you know, we can run fine on other levels and lower levels of the hardware just fine. The only PTFs you absolutely need, and I've mentioned this before, is the required or the base toleration fixes. And again, those have been identified with fix cats. We need you to put all of those required fixes on before you introduce your zOS into your environment, either as a zOS system or as a coupling facility image system. You don't have to put on those exploitation functions until you use the functions that they represent. But remember, when you do use those functions, a lot of them are sysplex related function, and you should be putting on those exploitation for the sysplex functions everywhere within the sysplex before you start to use that function. And you would need to have that done ahead of time. So you take a look at that and making sure that you've rolled it all the way around your sysplex before you start using those sysplex functions. As a reminder, as a recommendation, usually customers do not migrate their software and their hardware at the same time, and that's just to keep the quantity of change smaller in case they wanted to do a backup. And as always, you need to look at the restrictions and the migration considerations that we're telling you within this presentation and need to put them in your upgrade plan. So where is the official documentation found for upgrading zOS to run on the new latest and greatest level of the hardware? So there is no migration book anymore, as you know. We've converted everything to use a zOSMF upgrade workflow. And we have an upgrade workflow that is specifically written for the Z15, and it's its own workflow. We've also taken the Z15 upgrade workflow steps and we've put it into the larger zOS upgrade workflow. So you can find it in either one of those locations if you like. Now, for those that don't prefer to use zOSMF workflows and you want to see it on IBM documentation, we've also exported that Z15 workflow and provided it on IBM documentation. But really, it's just a simplistic export, and you're going to see a very big file, and it's just one words after another. You'll be able to search on it just fine, but it's really not going to be probably as usable as you want. And that's why I would encourage you to use the native format in zOSMF. Now, we also have an enhancement that we have incorporated in that we will be providing, and we have provided, the Z15 upgrade workflow in a PDF so that you can find it on your own zOS system when you have installed the PTF. And the PTF is for APAR OA60701. And after you've installed that PTF, you can look at your user LPP BCP upgrade path. And in there, you will see the Z15 upgrade workflow so that you could use it natively from that. It still does exist on GitHub, although we do know that we have a lot of problems with customers doing incorrect downloads and uploads from GitHub. And so that's why we decided to put it in a PTF so that you could find it on your zOS system easily. As you know, with every new hardware generation, we have new machine instructions, and so we have to support them with the high-level assembler. So the op table now supports ZS9 level, or and that's for the Z15, and we have an APAR on the high-level assembler that we have provided and marked as required so that you can identify it with the fixed cat in order to put it on. Now, the new machine instructions, the mnemonics may collide with the names of assembler macro instructions that you have. And so that's kind of something that we've always had a situation going on when we have a new hardware generation. So we have identified the new hardware instructions that you can see here in the tech doc that's provided. And if you have found that you have a conflict, there's some ways that you can see listed on this chart where you can avoid the conflicts. For IOCP for Z15 support. So IOCP is going to support the T01 and T02 base machine definition, including the MCS1 LPAR. We'll talk about MCS1 LPAR in a second. We've increased the coupling chipids per kek from 256 to 384. We've got support for increased coupling links to 96 and ICP to 64. Also, in zOS, before zOS 2.5, we had the IOCP FMID was HIO 1104, and it has been HIO 1104 probably since the beginning of my career. It's been that way forever. But what we had in zOS 2.5 is we changed the IOCP level to HIO 1105. Okay. What we're doing is we're putting this required PTF both on HIO 1104 and HIO 1105. So it'll be available on 2.5 and everything prior to zOS 2.5. For an upgrade, it is possible to use a Z13 or Z14 IOCDS if you're not going to use any new functions on the Z15. Of course, refer to the IOCP User's Guide for additional information. Now, HCD support for Z15, of course, just like IOCP, HCD has the base machine definition for a Z15 T01 and T02. And we also have the non-DPM mode IOCDSs on Z15 are going to contain support for the MCS1 LPAR. Now, the MCS1 LPAR is automatically activated during a dynamic I/O operation for the standalone coupling facility. And HCD, just like IOCP, has support for increased coupling chipids and also for increased coupling link ICA-SR from 80 to 96 and ICP from 32 to 64. The HCD APAR you can see is listed here. It's been identified with the SMPE fixed CADV required, and you'll need to that APAR on to write an IOCDS for Z15. Now, the dynamic activation of the new server or any of the adapter types can only be done on a Z15 or later. And this support has been provided back to zOS 2.1 because, as I mentioned before, that is the minimum level of zOS that we can run on a Z15.
Now let's talk about Sysplex. Let's talk a little bit about what your Sysplex needs to look like when you introduce a Z15 into the mix. As in other hardware levels on the Z platform, IBM supports N to N-2 levels of the hardware to coexist in the same Sysplex, which means in this case, your IBM Z15 can interoperate with Z14s and Z13s in the same Sysplex, provided that the down-level Z14 and Z13 systems have the ability through coupling links to communicate to the Z15, which means that they will need to use the ICA-SR or CE long-range coupling links. We'll talk more about that in subsequent slides. So this is a pictorial diagram of what we just talked about on the prior slide. So we may have a Z12, Z13, and Z14 and in a current Sysplex today. However, when we go ahead and want to bring in a Z15 into the mix, the ZEC12 or ZBC12 KEC will not be allowed to be in that Sysplex. So you have to, if you have a Z12 or of any flavor inside of your Sysplex, it will need to be removed if you want to bring a Z15 into that Sysplex. Business as usual. As IBM has stated for the last number of years, the Z14 MAMA, or the standard size machine, was designated as the last machine to support the HCA3 and the HCA3 long reach coupling link cards using the InfiniBand protocols. Those have been replaced by the ICA SR 1.1 for short distances and the Coupling Express LR or long reach for long distances. And so using the Z15, these are the options that you have available to you when you're doing coupling links at short or long distances. So how does that play out if I'm using Z13s and Z14s and Z15s and they are coexisting within the same Sysplex? Stay tuned for the next slide. I really love this chart because it really illustrates how a Z15 can interoperate and have coupling links between heterogeneous hardware levels in your Sysplex. So let's look first in the middle at the Z15, and this can apply to either a T01 or a T02. As we said before, a Z15 requires to use the ICA-SR for short distances or the Coupling Express long reach for long distances. So when the Z15 needs to interconnect with other down-level hardware machines, it will need to connect using those particular two cards, of course, depending on distance. That being said, now if we look at the upper two left and right here with the Z13 and Z14, those machines can still use the HCA3 and HCA3 long reach using InfiniBand protocol to communicate between themselves. They cannot communicate to the Z15, nor can they communicate to the Z14 ZR1, but they can communicate between the Z13, Z13S, and Z14 using those older cards using InfiniBand. Notice that the Z14 ZR1 does still have the same requirements as the Z15 in that it only supports the ICA SR or the CELR. So the bottom line with this chart is that you have a lot of flexibility in how you can set this up so that you can leverage the existing cards that you may still have. Let's now explore some of the ways you can exploit some of the major Z15 functionality in zOS. So here are some of the topics we're going to be talking about. You can read the list right here. We're going to be covering each one of these topics in the next subsequent slides. With the advent of a new hardware level comes a new CF level, in this case CF level 24 for the Z15. As with any other migration to a new level of the CF, it is important to run the CF sizer tool listed here to make sure that you may handle any increased storage requirements when moving from one level to the next. And as in prior CF levels, it's important to make sure you have at least 512 megabytes of storage available for your CFC microcode. Let's quickly talk about some of the coupling facility enhancements available. The first is CF Fair Latch Manager 2. And the idea with Fair Latch Manager is it provides improvements to the efficiency of scheduling and processing work targeted for, to system-managed duplex CF structures. The message path SYID resiliency enhancement is really zOS's improvement of and being able to recover from messaging path errors and to be able to dynamically correct on the fly and repair those messaging paths. The shared engine default being now dyne disp equals thin is just changing the default for shared engines. So for coupling facility partitions which share an engine amongst themselves, this allows that coupling facility to usually receive control faster and the dispatcher to give it control faster than before. And lastly, CF monopolization avoidance is a cool feature which prevents runaway applications from monopolizing a disproportionate amount of CF resources.
Let's look at the hyper dispatch enhancement we have on the Z15 for zOS. So currently processors are enabled for I/O from the highest configured CPU ID to the lowest. And if there was an LPAR weight change, that would cause the I/O enabled vertical highs and vertical mediums to be converted to vertical lows and then immediately parked by hyper dispatch. Because LPAR is going to always push the vertical highs and mediums to the lowest configured online processor. But with the zOS running on Z15, the order in which the processes are enabled for I/O interrupts is going to be reversed. So we're going to have SRM enabling processor for I/O interrupts from the lowest configured CPU ID now to the highest configured CPU ID. So what this does is it keeps the vertical high and the vertical medium processors enabled for I/O interrupts after the processor topology has changed. Let's look at a slip enhancement we have on zOS for Z15. So now with the slip command, we have additional options that we can specify to monitor and address or arrange for a key change and then take diagnostic action. To find the specifics of the slip command, use the command reference. Every time we have new hardware level, we have new extended counters. We've got crypto counters that are changing as well, and we have a new sample type happening on the Z15. So the support that we have for this has been added into zOS 2.2 and higher. You don't need any toleration support. We have required PTFs that you do need to have support on though. But remember, if you are going to collect the counters, you have to have HIS set up. So you'll want to start that on your system. If you want to look at the publications which describe the counters, you can see the books that are mentioned here. Now the Z15 machine language support is only going to be found in the zOS 2.4XLCC++ compiler level. And these new Z15 facilities that are going to be supported in this 2.4 level of the compiler you can see on this slide here. Let's look at cryptographic support now. So on the Z15, T01, and T02, we're going to have the ability to have more than 16 crypto express adapters. If you're on the Z15, T01, you're going to have the ability to have 60 crypto hardware security modules, HSMs. On Z15, you'll have T02, you'll have the ability to have 40 HSMs. If you have all Crypto Express 7, you can have a maximum of 60 HSM on a T01 and 40 on a T02. But remember that if you carry forward any Crypto Express 5 or 6, you cannot exceed 16 adapters, and the rest must be Crypto Express 7. So as is typical, we're seeing more functions in CCA support for additional algorithms. And we also have some updates to the Europay MasterCard Visa services that you will have and you need for new Visa requirements. And this is for software support only.
zOS Container Extensions, or ZCX, is a powerful feature first announced on zOS 2.4, which allows Linux on Z applications packaged as Docker containers to run directly on zOS inside of one or more ZCX servers. Each one of those servers has their own dynamic virtual IP address. If you have an OSA Express 7S or 6S on a Z14 GA2 or later, and you have the PTFs listed below, and I have inbound work queuing enabled for my OSA adapter, I can actually have traffic that comes into my zOS system segregated from my regular zOS traffic in its own ancillary input queue. So now our queue depths are not as deep for ZCX, and we're not interfering with the queue depths on the OSA card for our non-ZCX work. They're in separate queues. So that has a benefit in of itself of segregation. But what's really cool about this functionality is that because they're segregated and almost all the work in ZCX is zip eligible, that when zOS TCP/IP is processing that work on that ancillary input queue and delivering it to the ZCX server, even zOS TCP/IP will be dispatched onto zips. So again, this is assuming that you have enabled IWQ, that you have an OSA Express 7S or 6S, and that you have these PTFs installed.
For Rocky Express updates, we have some good news here. So we really needed to support multiple IP subnets, and this is something that we heard clearly from users. So we needed to support SMC version 2. And this SMC version 2 to support multiple IP subnets has been delivered in two pieces. One is for SMC-D for direct, and the other one is for SMC-R for routable Rocky. So you can see here that the SMC-D support has been provided in Z15 GA 1.5 and higher, and it has PTFs on communication server that you would need to install. And the SMC-R requires routable Rocky Express 2, that's on a Z14, and also associated communication server PTFs. So if you're interested in the multiple IP subnet support, this is a good chart for you to look at to see what's required. This is a real exciting area for the Z15 machine in the area of data compression. So on the Z15, the ZEDC functionality is moving on to the CPU in an area called the NXU portion of the CPU. It's known as the IBM Integrated Accelerator for Z Enterprise Data Compression. So when you're looking at zOS, we have APIs that can drive this accelerator, and we have them in both authorized and zlib APIs that are provided. And what's really nice is that all the existing software that has exploited these APIs, it's transparent whether you're going to be running on Z15 or Z14 and below, so that all your applications can still run. Now, data that was compressed on a ZEDC can be decompressed on the accelerator, and if it's compressed on the accelerator, it can be decompressed on the ZEDC. So this is really nice for compatibility purposes. So what do you need for using the Z Enterprise Data Compression? So it's only on a Z15, T01, and T02. You will need to install some PTFs for the support prior to having the z15 installed in your environment. So you are going to put those required PTFs on. If you don't have the PTFs on, it thinks, if it's on a Z15, it thinks it's going to go looking out for the old ZEDC Express devices, and it's not going to be able to find them. So you're going to need those PTFs on, and those have been marked as required. I would encourage you to use the ZBNA tool, which is provided at the website here, and this will provide some estimates in order to the value that you would get from using this acceleration for compression. But let's look specifically at zOS, because remember, zOS had a priced feature for the ZEDC. So how is that going to play into now getting the hardware function for free on a Z15? So all of the zOS configurations can stay the same. You don't really have any hardware fallback considerations or software fallback considerations, because we can transparently do that decompression or that compression information, compatibly, as I'd mentioned before. You do want to look at performance metrics for this compression accelerator, and that you will no longer see them in the RMF PCIe reporting area. You're going to need to find them in the RMF EADM reporting information as well. Now, synchronous executions onto the accelerator are not recorded because it's just an instruction invocation, but asynchronous execution will be recorded, and you will be able to see those. Let's look at this slide, because I do look at it a lot. It's got a lot of really good information on it. So now that we know, before Z15, we had a priced hardware feature called ZEDC, and we had a priced software feature in zOS called ZEDC. And you had to pay for both of those in order to use the ZEDC compression function. So we can see that on the left-hand side on, for example, here, the Z14. So here you have the exploiters that have been doing compression, and they're using the priced feature for zOS, and they're also using the priced hardware feature as well. And so that has all been great. We've got some lovely, happy customers using that compression. But what happens when you get to Z15 now? Because you don't have the hardware priced feature anymore. So that is just an accelerator that's included on the machine. But we still do have the zOS priced ZEDC feature. So which one of those items on the left-hand side do you have to pay for and to use for the zOS priced ZEDC feature, and which ones you don't? Well, it turns out to be which API that they're using. So if they're using the synchronous zlib API, and that is the ones that are on the right, that is no charge, meaning that you don't have to have the zOS priced feature for ZEDC to use that compression capability that you see on the right. However, we do have some exploiters of the asynchronous authorized usage APIs for that accelerator, and those are the ones that you will still continue to need to pay for with the zOS ZEDC priced feature. So in short, if you want to still do SMF log stream compression or QSAM, BSAM, or HSM DSS, the ones that you see in that shorter list, that's the red box on the right, those are the ones that continue to rely upon the priced zOS ZEDC feature. If you look at the box on the right of that, those are the ones that do not need the priced zOS ZEDC feature.
If you had to select one of the many great IBM Z15 features and label it as the flagship item of the hardware, I would look no further than System Recovery Boost. System Recovery Boost allows operating systems running on Z to use untapped resources to boost the performance during critical junctures during that operating system's processing. In particular, for zOS, it allows us to perform faster shutdowns and startups of the operating system without increasing IBM software licensing costs. So using System Recovery Boost, we're going to be able to have a faster shutdown for our planned outages, faster GDPS automation when we're reconfiguring and recovering our environments, faster startup of the operating system, middleware, and your applications to get back to steady state, And lastly, an additional boosted capacity for workload that may have built up while you were recycling the operating system. We're going to dive into it a little bit more on subsequent slides. So how does this boosting technology actually work? Well, there are several mechanisms of where your zOS system can take advantage of System Recovery Boost. The first one is something called Speed Boost. If you are running on a subcapacity machine model, if you use Speed Boost during these certain selected boost periods, you will be able to run at full machine capacity for that LPAR. So your LPAR will be dispatched at full capacity. So this is going to give you significantly maybe more MIPS to be able to run your workload much faster. In addition, we're going to give you the ability to throw extra engines at your particular work to be able to start your work faster. So increased parallelism can be achieved by using something called zip boost. Additional zips that may be on your system that you have defined as reserved zips can be brought online to your particular LPAR during the boosting period, and general purpose processor work that normally would only run on a general purpose processor can be dispatched onto a zip during the boosting period. This provides a significant more parallelism than you might otherwise have had you only had your pool of general purpose processors available to your LPAR. We also provide GDPS enhancements to increase the speed at which GDPS drives hardware actions. So let's talk a little bit about the boosting periods. You can use them twice per IPL. There's a 30-minute boost for shutdown, and there's a 60-minute boost for startup. So when I'm shutting down, I'm going to invoke a proc to kick off the shutdown boost. And that is going to give you more horsepower for a 30-minute period of time while you shut down your system. Then, when you IPL, you will have 60 minutes of boosting period, of which the speed boost, the zip boost, or both of those boosts can come into play to help you increase the speed of the engines that you're running, as well as the parallelism and having more engines to process this work. And we've seen clients that have significantly faster recovery times as a result of implementing System Recovery Boost. How much does this cost in additional licensing costs? Zero. How much do you have to pay in order to enable this base System Recovery Boost functionality? Also zero. So this is just a great technology that you can use and to facilitate a quicker recycle of your zOS operating system. The previous chart talked about the free System Recovery Boost offering. There also is a paid upgrade option available for the T01 model only. What this is going to do is to unlock additional zip capacity that is not otherwise available on the system. What does that mean? So when you get a new Z15, for example, you will have a number of processors which you've ordered, plus a number of processors that are already on that machine but are considered to be referred to as dark engines. Those engines are not used by any LPAR because you're not paying for those. Those would be for an increase in the model of the machine than what you currently have. I can untap up to 20 of those additional dark engines to be used as zip engines during a boost period. And so what's going to happen is, how do I do this? I'm going to have to get 2 hardware feature codes. I'm going to order these 2 hardware feature codes, and then I'm going to turn on this additional capacity through the HMC. Once I do that, I have now a 6-hour window of which I can use all of these additional dark engines. And so what I can do is to have a series of boosting period for maybe many different LPARs that reside on that KEK. So let's say I have 6 LPARs that are on that KEK that I want to do a rolling IPL for. Well, I can do a boosting period for for LPAR number 1, shut down and restart, and I can do the same for 2, 3, 4, 5, and 6 until my 6 hours have been exhausted. So this 6 hours is to give additional zip engine capability for various boosting periods that may occur on that system, and these are for IPL boosts, so shutdown and IPL recovery boosts. Now note that these feature codes have a initial limit of 30 activations. You can have a subscription that allows you to, replenish those 30 activations. And very important, these activations only apply to eligible boosting periods. Once you turn on this capacity, you don't necessarily get any capacity improvements until you do an action such as a shutdown and an IPL, which enables you to start a boosting period. Once you start the boosting period, these additional dark engines come online as zip engines, and I can now use those in conjunction with my zip boost to have tremendous additional parallelism in bringing up my system as fast as possible. So what do I need on zOS to exploit System Recovery Boost? Well, here are a list of APARs. You can also go and use the SMPE FixCat IBM Function System Recovery Boost to get the list of those PTFs and to install those PTFs onto your system that are required for exploitation. And just as a side note, that standalone dump also supports System Recovery Boost as well. So we talked about the T01 having an additional upgrade feature. Now, the T02 does not have that upgrade feature. However, depending on the subcapacity model that you have for a T02, you may have substantially higher subcap to full cap performance ratios. So what that means is that a speed boost may actually boost your workload even more than it would have on a T01 machine. And similarly, since the zip processors always run at full cap speed, the potential benefit from a zip boost may be much larger than is possible on a T01. So again, you may want to consider purchasing additional zip engines on a T02 to leverage this enhanced free boost that occurs on a T02 as compared to most T01s. And so again, you cannot use the upgrade capability of the System Recovery Boost, but you have other benefits which in some cases may exceed the benefits on T01, which would make up some of the fact that you can't order the upgrade boost on the T02. So System Recovery Boost is not now just for shutdowns and startups of the operating system, but it also provides significant functionality for certain sysplex recovery events that may take place on your system. So in addition to the IPL and shutdown boosts, we now provide recovery boosts in a much smaller scope for an occasional sysplex recovery activity. So when you have certain sysplex recovery activities, such as sysplex partitioning, such as CF structure recovery, such as CF data sharing member recovery, or hyperswap, you may experience a big spike in the amount of work that's required by the operating system to handle those particular events. With sysplex recovery boosts, you can have very short-term boosts, usually 5 minutes per boost, of where you can have enhanced boosting capabilities. And so using the speed boost and or zip boost we can actually now boost these 4 Sysplex recovery activities up to 30 minutes per LPAR per day. And again, the most beautiful thing about Sysplex recovery boosts is that, again, there's no increase to IBM software licensing costs. This boost is not reported to the reporting software that is used to track, again, your monthly licensing charges, and so you will not see a bump in your IBM software licensing costs. For more information, we would encourage you to check out this link listed at the bottom of the screen. This is a great chart that Marna has put together that sort of demonstrates how you obtain support for a lot of the functionality that we've talked about over the last 45 minutes or so. And in particular, do you need PTFs? Do you need web deliverables? Is it just part of the base operating system? And by operating system, you can see which functions are available or not available, which ones you need a PTF for, which you need a web deliverable for, and which things are in the base. And so this chart is my go-to chart when determining what I need in order to exploit these major functionality items on the Z15. Marna and I would like to thank you for joining us for this exploration of the zOS support for the IBM Z15. If you have any questions, you can ask them right now as we are here live to answer your questions. However, if you'd rather do it offline, you can send us an email using our email addresses found on the title page, and we will be glad to get back with you at a later date and time. Would you also take a moment to fill out the session evaluation survey for the GSE UK? That will allow the GSE UK planners to know what you thought of this particular session. Thanks a lot.
Thanks, Steve. Thanks, Marna, for another brilliant session. Not a single question in the chat so far, just Marna critiquing her own slides on the go, which is always good. Do we have any questions at all for Marna and Steve? Now is the time.
Well, I guess Marna and I just covered every single thing that you possibly could want to know.
Yeah, I guess so, yeah. And the handout should be up on the session onto the website, so there's lots of information in the proceedings that we also didn't have time to cover too.
Perfect. Well, listen, yeah, if there's no questions, let's leave it there. Everyone's got your email addresses, surely. If they've not, please get in touch with me or look at the slides up there on the website. And we'll be back on air with Large Systems at 3:30. Steve, you're coming back to do part 3 of your ZCX session, talking about some use cases, which should be interesting. So hopefully see you for that. With that, I'll shut it down there. Thanks all for listening.
Thank you, guys.
Bye-bye.